Across multiple data link layer transports such as ATMs, frame relay, or Ethernet. So this is the major benefit of MPLS. Yes, this picture tells about the process of MPLS. First, there is an incoming packet. IP packet is reaching this LER. So the LER, the ingress LER, attaches the label L1 to it and forwards it to the LSP. That is to the next LSR. So there, what happens? The label L1 is being removed over here and it attaches a new label L2 and forwards to the next point. And in that, L2 is been removed and new label L3 is attached and forwarded to the last point. So this is the egress edge router, label edge router. So it removes the label and sends only the IP packet to the destination. So this is another example of the MPLS operation. So a station A sending a packet to station B. Based on the protocol, it founds the path can be R1, R2, R3, and R4. So this is called as a edge LSR, and these are called as a core LSR. So let us look at the table. So, which is the label forwarding information base. As we have already seen, this LFIB contains details about the or mapping between the labels and the interfacing points. So, initially the packet comes to R1 without any incoming label, and now only the label 6 has been attached and it has been forwarded. So, what is the incoming interface and what is the outgoing interface? We'll move on to the previous slide and check. For R1, router R1, the incoming interface is E0 and the outgoing interface is S1. Yes, for R1, the incoming interface is E0 and the outgoing interface is S1. So all these interfacing related information will be present in this LFIB. Similarly, when it goes to the next one, it will be having the previous label 6, but now every node will remove the existing label and it will attach the new label. Similarly, that thing happened with the R3 router also, and since R4 is the next edge router, it is the egress router. So it will have an incoming label, but that will be removed. And when it is going out of that node, there will not be any label, only the IP packet reaches the destination. So this is another picture which is saying about the label removal process. So yes, there is a label switch path and the routing protocols follow FECs, and when it all the details will be stored in the LFIB data. So first thing is the incoming data. Yes, a data comes to the ingress node. So after that, it goes to a the ingress node adds a new label and then it forwards to the core node. In that, the new label will be added. Yes, that is called as label swapping will happen. And finally, when it goes to the egress node, the label will be removed and sent to the destination. And then how do we do this label encapsulation? So this label encapsulation can be done in three ways. Either that label detail can be added along with the network layer header or data link layer header. Otherwise, a new label header, which is called as a shim label header, can be inserted between the both the layers. So three possibilities are there. We look into the label encapsulation. So these are the labels of all the other protocols of the data link layer. Yes, the data link layer protocols are there and its labels are there. Along with that, the shim label can be inserted and then forwarded. Yes, it has been inserted in between the L2 header and the L3 header. So what is a shim header? The shim header is having these entries: label, experimentation, and then S and TTL, which is the label. So we have seen in the previous slides, the label 6 has been used, 15 has been used. So there are some values available. So the label value can be either between the 0 to 15. So total